Hey everyone, my name is Kuchen and our project for TEW is about the data running, also visualization. So in simple terms, data running is the process of cleaning and also preparing the raw data so that it can be analyzed, while the visualization is about using charts and graphs to communicate with the insights. So both are very important in the data science because real world data is often messy. So in our project, we apply this technique to the automobile data set to answer the several research questions about the car performance and also the efficiency. Okay, so for the first one is we'll go through the dataset description. So we choose the automobile dataset from the UCM machine learning repository. It contains around 400 cars produced between the years 1970 and the years 1982, with 9 total attributes in total. So the key attribute include MPG for fuel efficiency and then horsepower, weight, acceleration for the performance, and also model years for the production years. And also the last one is origin, which show the whether the car is from USA, Europe, also Japan. So we choose this dataset because it's both numeric and also the categorical data, so cover multiple years and regions, and allow us to explore the meaningful questions like how fuel efficiency changes over the time, and the relationship between the horsepower and MPG, the connection between weight and also accelerations, and the regional difference in the car performance. Okay, so now we'll go through for the data running part. So after the description of our data set, the next step was data running is very important. So because the raw data set contain a missing value and also an inconsistent format, so I will show you the main screenings that we apply in our project. So the first one in cell 3 here. So I began for exploring the dataset. I checked the overall shape and which has around 400 rows and although 9 columns. I also measured memory usage and also confirmed the dataset types for each column. So lastly, I displayed the first 5 rows to get the clear sense of the dataset structure before cleaning. Okay, so for the next cell 4 is missing value and so data range. So I examined the missing value across all the columns. For example, the horsepower column had some missing value entries. So I checked the data range for numeric columns such as the minimum and also maximum value and the review unique value for the categorical columns. And this step ensure that we understand that where the data can has gap and also whether any values for unusual. So the next one is cell 5. Okay, for cell 5 is handling missing horsepower. So I handle missing value specifically in the horsepower column. I replaced each missing value with the median horsepower of car that had same number of cylinder. After that, I converted the horsepower into the numerical format and filter any remaining add with the overall median. So this makes the dataset cleaner and also avoid removing the rows unnecessarily. So for the next is creating the derived features. So in cell 6, I created the new derived features to enrich our analysis. So this included the power to weight ratio, efficiency category based on MPG, dedicates of manufacturer, and also engine size category. These derived features allow us to analyze the car performance and efficiency more meaningfully. Okay, so for the last cell is data quality validation. So I validate the dataset after the Wrangling. First, I confirm that no missing value remain, and then I perform outlier detection on the numeric columns using the interquartile race method. Finally, I review the dataset shapes and then list out the columns and memory usage. So at this point, our dataset was fully clean and structured and ready for analysis. So for this data running step, we transform the dataset into a clean and consistent form. So this allows us to move forward confidently to the exploratory analysis and also the visualization stage. So that's all for me. Thank you.
Good day everyone, my name is Goshinda and now I'll present the section 3 exploratory data analysis of our automobile dataset. So the first one, we have implements the descriptive statistics to know the entire structures of this dataset, and the second is the other statistics method by origins, country, and like the statistics by decade, and then we get those results. And then we also apply some advanced statistics analysis, for example like the Innova test for MPG difference by origins, chi-squared test for efficiencies categories by origins, multiple regressions analysis, and so on. So let's move to the key finding. The first one is the fuel efficiency leadership. The Japanese car average 30.5 mpg versus USA 20.1 mpg, a 52% difference. The Europe sit in the middle at 27.9 mpg. So the second one is about the power efficiency trade-off. We found strong negative 0.776 correlations between the horsepower and the fuel efficiency. The higher power directly reduces the efficiency. And the third one, which is the weight matter, the car average 2,970 pounds, and our power to weight ratios show the strongest correlations with accelerations performance at negative 0.726. The last one, which is the temporal improvement, the car improved with 70.7 mpg in 19 and 70 years to 39.7 mpg in 1982, a 79% improvement. So all the findings are statistically significant with p-value less than 0.001. Our machine learning model achieved 91% accuracy, confirming these relationships are robust and predictive. That's all for me, and now I'll pass to the next presenter.
Hi everyone, my name is Ahmad Zakam Ahmad, and today I'm going to present for data visualization part. And the first analysis we do is the distribution analysis. So for distribution analysis, we will be using histogram and the box plot. So for example, I take is the distribution of MPG histogram. So approximately unimodal and exhibit a slight right skew. So this indicates that while most cars in the dataset have a fuel efficiency clustered around the central value, which is 33.5 around here, and the median is 23, so there is a long tail extending towards the higher MPG values. So this tail represents a smaller population of highly fuel efficient vehicles. And for the box plot of MPG, there's a one clear high value outlier, which is this one. So this vehicle demonstrates exceptionally high fuel efficiency compared to the rest of the fleet, and it's a statistically significant anomaly. So for other example and explanation, you can see inside our report. So moving on to the next analysis is the relationship analysis. So for relationship analysis, we'll be using scatter plot metrics, and here are the key variable for the scatter plot metrics, and we also do correlation heat map. So understanding this relationship is crucial for identifying patterns, predicting behavior, and uncovering the underlying mechanics of the automotive data. So two powerful visual tools I employed in this purpose, as I mentioned just now, is the scatter plot metrics and the correlation heat map. So I've take one example of the key analysis of the pairwise relationship. So you can take the mass per gallon versus horsepower, weight, and displacement. So it shows a strong, clear negative linear relationship as the values of horsepower, weight, and engine displacement increase. So the value of the mass per gallon, which is fuel efficiency, consistently decrease. This is one of the most fundamental and expected relationship in automotive engineering. And the larger, the more powerful, and more heavy engines are less efficient. And the points are tightly clustered along this downward trend, indicating a strong and reliable correlation. And moving on to the correlation heat map numeric variables. As you can see here in the heat map, red indicator meaning there's a high and strong correlation relationship between the variables, and the blue is the low relationship between the variables. More details you can find inside our report. So moving on to next is the key relationship analysis. So the first plot you can see here, we can see that USA has the high horsepower and low miles per gallon. Japan has a lower horsepower and high miles per gallon. And in Europe, there are some vehicles matching Japanese efficiency and others approaching American power levels. So this reflects a diverse market prioritizing a balance of performance and efficiency in Europe. For other plot, you can see more detailed explanation inside our report. And lastly, we do interactive visualization. So for interactive visualization, we use scatter plot, which is MPG versus horsepower by origin, which means we filter by country. And there is a 3D scatter plot, and then interactive time series, interactive box plot, and interactive correlation map. So this interactive MPG versus horsepower by origin, it's a map that it's interactive where it shows the details of the data if we hover over them. So same goes to other part also. And more details and explanation you can find inside our report. So this is the interactive correlation heat map. Here, as we know, the red is we have the highest strong correlation, and the blue has the weakest correlation. And moving on to next is categorical analysis. So for categorical analysis, we do MPG by origin box plot, and then horsepower by origin box plot, cylinder distribution, origin distribution, efficiency category analysis, efficiency category distribution, and efficiency by origin. So for example, I take one here, MPG distribution by origin. As you can see here, the highest median and Japan has the highest median and the smallest interquartile range, so superior fuel efficiency but also remarkable consistency. And USA has the lowest median and largest interquartile range, so the worst average fuel economy and the greatest variability in efficiency among American cars. For Europe, it's higher than the USA but lower than Japan, and the compact interquartile range suggests a focused engineering philosophy on balance, moderately efficient vehicles. And for other example, you can for other part you can see more detailed explanation inside our report. So that's it from me. Thank you.
Hello, my name is Rais Arkawarisme. For the part 5, discussion and analysis. How fuel efficiency change over time? The first proposed question. We do the yearly and origin group by. In the yearly, in the 70, we get the MPG 1969, and at the end of the data set, we get the 82, which get us 31.71, which is basically over time, the miles per gallon is better and increase efficiency. For the origin, US is the most less efficiency, while Japan is the highest and Europe in the middle. For the second question, what is the relationship between engine horsepower and fuel efficiency and MPG? The first part, we calculate the correlation, which get us negative 0.776, which is negative high correlation, which lead by USA, and then followed by Japan and Europe. This is due to the the coefficient MPG change per 1 horsepower increase. This is categorized by the 31.34 efficiency, meaning that the horsepower is low and the highest horsepower will cause 15.14 mpg. And the third proposed question is, how do vehicle weight and accelerate correlate? So we do the overall correlation for weight and acceleration, which then we get the moderate negative correlation between weight and acceleration. And then we do the Y origin, which then we got USA and Japan as negative, moderately negative correlation, and Europe slightly positive. We do the correlation by decade, and then we see that in the 70s, it is moderately negative correlation and shifting to the slightly positive in the 80s. And then the last question, which origin country produced the most powerful car and how does this relate to fuel efficiency? We do the power analysis by origin, which we get then USA having the highest horsepower and Japan lowest horsepower. We then do the listing for each Y origin for each US, Japan, and Europe. We can see the most powerful car listed. And then power efficiency analysis. We get the US since it has the highest horsepower. The efficiency is the lowest compared to Japan. Since Japan has the lowest horsepower, it has the highest miles per gallon, which is full efficiency is better, while for Europe is in the middle. In conclusion, the overall analysis suggests that manufacturers should pay more attention to optimize power to weight ratio displacement since this factor most strongly influence performance and efficiency for customer. Thank you.